In this video, we're going to talk about the graphs of exponential growth functions. And we're going to look at what these kind of functions look like and their basic characteristics. I have written here 4 different exponential growth functions. Right? So exponential growth functions, they can have a variety of different ways they can look. But the defining characteristic of what makes these exponential functions is the fact that our x variable, right, is the exponent here, right? 3 to the x power, this is 1/2 times 6 to the power of x, 2 times 5 to the power of x, 600 times 1.05 to the power of x, right? Or I could even write one like this, right? Y is equal to 3 times 7 to the x minus 3 power, right? Again, the key thing is that I have my x value as part of the exponent, right? That's what's going to make it exponential. All right, so let's graph this function as an example. F of x equals 3 to the power of x. Right? So we're going to construct an input-output table and then do our graph. All right, for our input-output table, I'm going to put a whole bunch of values here. Let's see, we're going to go from -4 all the way, and I need some more space, to +4. All right, and I'll do some of these, and you will do some of them on your own. All right, so I'm actually not going to start at the beginning here. I'm going to start in the middle, do some of the positives first, and then go back and do some of the negatives. All right, so let's figure out what happens when we input 0. What's our output going to be? All right, well, when I input 0, so f of 0 would be 3 to the 0th power. Well, 3 to the 0th power is 1. So f of 0 is 1. So my output for when I input 0, my output would be 1. All right, let's continue. So let's see what happens when I input +1. Well, when I input 1, I'm going to get 3 to the 1st, which would be 3. So my input is 1, my output's 3. All right, let me do one more positive exponent. Let's see what happens when I input 2. I'm going to get 3 to the 2nd power, so f of 2 would be 9. Okay, all right, let's do some negative powers now, right? So what happens when I input a -1? So let's do this over here. F of -1 would be 3 to the -1st power. So f of -1 would be, that's a third. All right, so this is going to be 1/3. Now let's do an input of -2. What happens when I input -2? So f of -2 would be 3 to the -2nd, and 3 to the -2nd is 1/9. So this should be 1/9 here. All right, I think I've done enough. I would like you to finish. So go ahead and figure out the outputs for inputs of 3 and 4, and inputs of -3 and -4. So please pause and finish the input-output table. Okay, you should have been able to do that pretty easily. Let's see, when you input 3, you get an output of 27. When you input 4, you get an output of 81. When you input -3, you get an output of 1/27. And when you input -4, you get an output of 1/81. Right? All right, so I want you to see what's happening here. Right? When our input here gets bigger and bigger, right, what's happening to our outputs? Right, these are getting huge, right? 1, 3, 9, 27, 81, right? They're going to get really big really fast, right? And over here, as the inputs get smaller and smaller, right, these get smaller and smaller, right? Or I should say, as these get more and more negative, these get smaller and smaller, right? This fraction gets really, really small. All right, so let's go ahead and graph this. All right, so in my graph, let me kind of zoom in on my graph here. In order to fit all this in my graph, I'm going to use a different scale for my x and y, right? And that's because I need this to fit. Okay, so for my x values, I'm just going to count by ones here, right? So this would be 1, 2, 3, 4, and then on this side, -1, -2, -3, -4, -5. Right? But for my output, my y values, I'm going to count by, I think I'm going to count by 10, so I can go try to fit 80, 81, right? So this is going to be 10, 20, 20, 30, 40, 50, 60, 70, 80. I'm not going to write all of those. All right, but you guys get the idea. Okay, but again, the purpose of counting by having a different scale for the x and y is so that things will fit, right? Okay, so let's go ahead and graph these. So I have the input-output pair 0, 1, so that would be somewhere here, right? I have 2, 9, oh, I'm sorry, I skipped 1, 1, 3, which is about here, 2, 9, which is about here, 2, 9, 3, 27, it's over here, and then 481, it's going to be way up here. Okay, on the other side, I have, let's see, input of -1, and then I have a third, right? That's really small. I didn't even draw that very well, but somewhere over there, right? -2, I'm going to have 1/9, which is going to be somewhere here, right? -3 is 1 over 27. That's a really small fraction down here, right? -4, it's going to be 1 over 81. That's a super small fraction down there, okay? All right, so what does this graph look like? It looks like this. Okay, and again, I want you to see what's happening. When our x values get really, really big, these positive numbers get really, really big, right? The output just shoots up. It gets really, really big, really fast, right? The next one, if I had room, right, when the input was 5, this is going to jump all the way to 243. It goes up really, really fast. Okay, and then on this side, when my negative x values here, they continue to get more and more negative, right? This fraction just gets really, really small. A third, 1/9, 1 over 27, 1 over 81. It gets really, really small. But then you'll notice that this is never going to go to 0. It's never going to be down here in the negatives. It's never going to pass 0. It's just going to be really, really small fractions. 1/3, 1/9, 1/27, 1 over 81, 1 over 243. It's just going to get really, really small, right? But it's going to stay positive.